Right now, something from another star system is racing through our solar system at 58 kilometers per second, and scientists have no idea what to make of it. This is 3IATLAS, detected just 3 months ago, and it's already rewriting everything we thought we knew about interstellar visitors. Stick around, because what I'm about to show you is going to blow your mind. July 1st, 2025. A robotic telescope in Chile, part of NASA's ATLAS system, captured something that shouldn't be there. At first, it looked like just another faint dot moving against the stars. But when astronomers calculated its speed and trajectory, alarm bells started ringing. This thing was moving way too fast. We're talking 58 kilometers per second, fast enough to escape the sun's gravity completely. Within hours, observatories worldwide started digging through their archives. And here's where it gets crazy. They found images of this object dating back to June 14th. It had been there all along, and nobody noticed because it was so faint and so fast. The Minor Planet Center in Massachusetts immediately flagged it as something special. They calculated its orbit and realized this wasn't bound to our solar system at all. It came from interstellar space, from beyond our cosmic neighborhood, making it only the third interstellar object ever detected. They named it 3IATLAS. The 3I means third interstellar, and ATLAS is the telescope system that officially discovered it. Now here's what makes this discovery different from the previous 2 interstellar visitors. When Oumuamua showed up in 2017, we caught it as it was leaving. By the time we realized what it was already past the sun and accelerating away into deep space. We had maybe a few weeks to study it before it became too faint to observe. Borisov, discovered in 2019, gave us a bit more time, but it was still moving pretty fast. But 3IATLAS? We caught this one early. It was still beyond Jupiter when we found it, which meant scientists had months to prepare, to point every major telescope at it, to gather data before it made its closest approach to the Sunday. And they needed that time, because 3IATLAS immediately started doing things that made no sense. Let me break down why astronomers are losing their minds over this object. First, the size. Early estimates suggested the nucleus could be up to 10 kilometers across. That's massive for an interstellar object. Oumuamua was maybe 100 meters long. Borisov was 1 to 2 kilometers. But 10 kilometers? That would make 3IATLAS gigantic. Later observations from Hubble scaled that estimate down to between 440 meters and 5.6 kilometers. But even at the lower end, it's still huge. Second, the brightness. Between May and June, 3IATLAS got 5 times brighter than it should have based on distance alone. NASA's TESS satellite captured this brightening event completely by accident while it was scanning the sky for exoplanets. The data showed the comet's magnitude jumped from around 20 to 19.28 inches less than a month. That kind of sudden brightening means the comet was actively releasing gas and dust when it was still 6 astronomical units from the Sunday. Most comets don't start outgassing until they're around 3 AU or closer. So what was 3IATLAS releasing that could vaporize that far out? Probably something super volatile, like nitrogen or carbon monoxide. Materials that turn to gas at extremely low temperatures. Third, the composition is completely weird. When the James Webb Space Telescope observed 3IATLAS in August using its infrared spectrograph, it found that the coma was dominated by carbon dioxide and carbon monoxide, with very little water. That's the opposite of what we see in most comets. Solar system comets are mostly water ice, but this thing? It's like 90% carbon dioxide. That's bizarre, and suggests it formed in a very different environment than our own solar system, probably somewhere much colder. Fourth, there's metal in the coma, specifically nickel. Now, comets do contain trace metals, but they only release them when they get incredibly close to the sun, close enough that the heat literally vaporizes metal. 3IATLAS was releasing nickel when it was still between Mars and Jupiter. There's no natural explanation for that. Either the metal is embedded in dust grains that are fragmenting and releasing it, or something else is going on. And if you're thinking what I'm thinking, yeah, rocket engines are typically made from nickel alloys, and when they burn, they release nickel into the exhaust. But we'll get to that theory in a minute. Fifth, the trajectory is suspiciously stable. Most comets experience what's called non-gravitational acceleration. When ice vaporizes on the surface, it creates jets that push the comet around like tiny rocket thrusters. This causes the comet to speed up, slow down, or change direction unpredictably. Oumuamua had extreme variations, sometimes changing its trajectory by over 1,000 kilometers per day. Borisov fluctuated by about 100 kilometers per day. Even Hale-Bopp, one of the biggest comets we've ever seen, moved around by 10 kilometers per day. But 3IATLAS? It's only fluctuating by 1.5 kilometers per day. That's almost nothing. It's holding an incredibly steady course, so steady that you could almost think it's being guided. And finally, there's the age. Based on its velocity and statistical models that correlate speed with stellar age, astronomers estimate 3IATLAS could be anywhere from 3 to 11 billion years old. If it's on the higher end, that makes it older than our entire solar system. This thing could have been drifting through the galaxy since before Earth even existed. Here's where things get absolutely wild. On September 7th, during a lunar eclipse that created some of the darkest skies possible, 2 amateur astronomers in Namibia pointed their cameras at 3IATLAS. What they captured has scientists completely stumped. The comet was glowing bright green. Now, green comets aren't unusual. We see them all the time. The color comes from dicarbon molecules, or C2, which is just 2 carbon atoms bonded together. When these molecules get hit by ultraviolet light from the sun, they fluoresce at around 518 nanometers, right in the green part of the spectrum. It's a well-understood process. Except here's the problem. Every spectroscopic analysis of 3IATLAS shows it's severely depleted in dicarbon. Multiple observations from professional telescopes, including Gemini South, measured the C2 to Cn ratio and found it to be incredibly low, less than 0.09. For context, normal comets have ratios closer to 1. This makes 3IATLAS one of the most carbon chain depleted comets ever observed. So if it has almost no C2, why is it glowing green? Nobody knows. There are a few theories. Maybe C2 production suddenly ramped up as the comet got closer to the sun and the earlier measurements missed it. Maybe the green color is coming from something else entirely, some emission process we haven't identified. Certain metal atoms can emit green light when excited by UV radiation, but none of the metals detected in the coma so far produce green at the right wavelength. Or maybe, and this is the least likely explanation, the green glow is an imaging artifact, something to do with the cameras or atmospheric scattering. But professional observatories haven't confirmed the green color yet, so the mystery remains open. On September 25th, something dramatic happened. A coronal mass ejection from the sun, basically a massive burst of plasma and magnetic fields, slammed directly into 3IATLAS. CMEs are common. But what made this one significant was the timing and intensity. The comet had moved closer to the sun, and the CME hit it pretty hard, ionizing the coma and potentially causing major changes in its structure. Geophysicist Stephen Burns, who's been tracking 3IATLAS closely, reported that right around the same time this CME hit, 2 nova explosions were detected in distant star systems, and 2 magnitude 6+ earthquakes struck Venezuela within hours of each other. Now, these events are almost certainly unrelated statistically, but the clustering of unusual activity from Earth to the Sun to deep space has people talking. Burns also noted that 3IATLAS's coma appeared to expand significantly after the CME impact, possibly due to increased ionization and gas release. Recent imaging from the Lowell Discovery Telescope on September 15th showed the coma extending roughly 100,000 kilometers from the nucleus, with a faint tail stretching even further. But here's something weird. Professional telescopes consistently show an anti-sunward tail, which is what you'd expect. Dust gets blown away from the sun by radiation pressure. But amateur astronomers keep capturing images showing material extending in the sunward direction. This disparity likely comes down to what wavelengths they're observing. Professional instruments use narrowband filters that isolate specific emission lines, while amateur gear captures broadband visible light. The combination creates the appearance of dust moving in opposite directions. Polarimetry studies published in early September revealed another anomaly. Researchers using telescopes in Chile, the Canary Islands, and Bulgaria measured how light from 3IATLAS was polarized as it scattered off dust in the coma. What they found was unprecedented. The comet exhibits an exceptionally deep and narrow negative polarization branch, meaning light is scattering in a way never seen before in any solar system comet or asteroid. Even Borisov showed positive polarization. This unique signature suggests the dust grains in 3IATLAS's coma have properties we don't understand, possibly different sizes, shapes, or compositions than anything we've encountered. The rotation period is still uncertain. Early observations suggested 29 hours, but the light curve was unusually flat, showing minimal brightness variations. More recent studies detected periodic signals at 16 hours, which might be the true rotation period. But the data is noisy, and we need more observations to confirm. Let's address the elephant in the room. Is 3IATLAS an alien spacecraft? Harvard astrophysicist Avi Loeb certainly thinks it's possible. In July, shortly after the discovery, Loeb published a paper arguing that 3IATLAS was statistically too large to be a natural asteroid based on the density of material in interstellar space. Days later, he followed up with another paper titled, "Is the Interstellar Object 3IATLAS Alien Technology?" In it, he explored whether the comet's trajectory could be the result of deliberate navigation, invoking the dark forest hypothesis that alien civilizations might be hiding from each other. Loeb pointed to several features as potentially suspicious: the steady trajectory, the release of nickel at unusual distances, the carbon dioxide-dominated coma that could resemble rocket exhaust, and the planetary grand tour trajectory that brings it close to Mars, Venus, and Jupiter, while avoiding Earth. He suggested these could be signs of an artificial probe conducting reconnaissance of our solar system. The scientific community pushed back hard. Multiple researchers, including geoscientist AKM Ehsanul Haq, published rebuttals systematically dismantling Loeb's arguments. They pointed out that by the time Loeb's papers were published, Hubble had already revised the size estimates downward, making the object far less statistically improbable. They also showed that the trajectory could be fully explained by natural gravitational dynamics without invoking any non-gravitational acceleration or deliberate course corrections. The flybys of various planets are coincidental, not engineered. The controversy highlights a fundamental tension in modern astronomy. On one hand, we should explore all possibilities, including unconventional ones. On the other hand, extraordinary claims require extraordinary evidence, and we haven't exhausted natural explanations yet. The truth is, 3IATLAS is almost certainly a comet, just a really weird one. But the fact that we're even having this conversation shows how little we still understand about interstellar objects and how they behave. Here's the timeline for the next few weeks, and it's going to be intense. On October 3rd, just days from now, 3IATLAS will make its closest approach to Mars, passing within 0.2 astronomical units, about 30 million kilometers. This is the closest any interstellar object has come to another planet in recorded history. Mars-orbiting spacecraft, like MAVEN and the Mars Reconnaissance Orbiter, will be watching, potentially detecting particles from the comet's coma, interacting with Mars's thin atmosphere. On October 21st, the comet reaches superior conjunction with Earth, meaning it'll be directly on the opposite side of the Sun from our perspective. At this point, the Sun's glare makes direct observation impossible from Earth-based telescopes. We'll effectively lose sight of it for about 6 weeks. Then comes October 30th, Perihelion. This is the moment of truth. At 1.4 astronomical units from the Sun, roughly 210 million kilometers, 3IATLAS will experience the most intense solar radiation it has felt in potentially billions of years. This is when things could get dramatic. If there are volatile ices buried beneath the surface, they'll start vaporizing violently. The comet could undergo massive outbursts, releasing enormous amounts of gas and dust. Its tail could stretch for millions of kilometers, or it could fragment entirely. Comets are fragile, and many don't survive close approaches to the Sunday. If 3IATLAS breaks apart, we'll witness the death of an object that traveled for billions of years across the galaxy.
Space-based observatories like SOHO, which sits between Earth and the Sun and uses a coronagraph to block solar glare, might be able to capture images during perihelion. NASA's SPHERE-X telescope and the MAVEN orbiter at Mars could also have observation opportunities. By early December, 3IATLAS will re-emerge from behind the Sun, visible again from Earth. If it survived perihelion intact, it'll be far more active than before, with a much larger coma and tail. This will be our last chance for detailed observations before it accelerates back toward interstellar space. Every major telescope will be pointed at it, capturing spectra, measuring brightness, analyzing composition. These post-perihelion observations are critical because they'll show how the comet changed, what new materials were released, and whether the nucleus fragmented. Here's where we get into pure speculation, but it's speculation worth considering. In August 1977, astronomers at Ohio State University's Big Ear Radio Telescope detected a narrowband radio signal lasting 72 seconds. The signal was so unusual, so powerful, that the astronomer reviewing the data wrote, "Wow," in the margin of the printout. The WOW signal, as it's now known, remains one of the greatest unsolved mysteries in the search for extraterrestrial intelligence. The signal originated from the direction of the constellation Sagittarius, and it was broadcast at 1,420 MHz, the hydrogen line. Hydrogen is the most abundant element in the universe, and the hydrogen line is a naturally occurring radio frequency that any scientifically advanced civilization would recognize. If aliens wanted to send a simple message that would be noticed, broadcasting at the hydrogen line makes sense. The signal was never detected again, despite decades of follow-up observations. Now here's the connection. Astronomers have traced 3IATLAS's trajectory backward, and it also came from the direction of Sagittarius. In 1977, when the WOW signal was detected, 3IATLAS would have been on the outer edge of our solar system, beyond Pluto, far too distant to be detected with 1,970 seconds technology. Could the signal have come from this object? Could it have been announcing its arrival? It's an incredible coincidence, and it's captured the imagination of space enthusiasts worldwide. To be clear, this is almost certainly not true. The WOW signal probably came from a distant star or some natural phenomenon we don't understand yet. And 3IATLAS is almost certainly a natural comet, not an alien probe. But the coincidence is striking, and it raises interesting questions about how we would recognize an artificial signal if we ever received one. The truth is, we don't know what 3IATLAS really is. We have more questions than answers. Why is it releasing nickel? Why is it glowing green when it shouldn't have the chemistry to do so? Why is its trajectory so stable? Where exactly did it form? And what was that environment like? These are mysteries we're actively trying to solve, and the next few months will provide crucial data. As the comet rounds the Sun and re-emerges in December, we'll have one final chance to study it before it leaves our solar system forever, returning to the darkness between stars. This is why 3IATLAS matters. It's not just a comet, it's a visitor from another star system, carrying information about environments we can't reach with current technology. It's a time capsule from billions of years ago, a relic of an ancient era of the galaxy. And it's forcing us to expand our understanding of what's possible, to question our assumptions, and to keep looking up, because the next interstellar visitor could arrive at any moment. The universe is vast, dynamic, and filled with objects we never imagined. 3IATLAS is proof of that, and whatever we learn from it will shape how we study the next visitor and the one after that, building a catalog of interstellar travelers that will eventually tell us what the galaxy is made of and whether we're alone. The countdown to perihelion is on. The next few weeks will be historic, and if you want to follow this story as it unfolds, stay tuned, because this is just the beginning.